I could not visit my sites in Russia in spring to set up an excursion for you. So we visited with my partner Jürgen de Meyer in Germany, in Saxony. It is called Dubringer Moor, and to my taste is quite in the set status. However, it has status of Natura 2000. In the middle of the area there is the site called Hedermeyer. It is a former peat cut area. Peat was cut by hand. It was partly restored by itself and with some additional measures. Today we will use the area for explaining how to set up the vegetation relevé on the site. As we learned during our landscape mapping exercises, the basic landscape unit in peatland is face, or microlandscape. At this part of our peatland, we identified 5 faces. We are marking borders by yellow lines. Let's choose one for our relevé, and it is marked here by a red tick. And we remember that at every level of landscape which we are carrying out our survey, we have to address all components: peat, water, vegetation, biota. So first we mark the center of our future relevé. For this I usually use the quarter. Here 10 meters, here 10 meters, here 10 meters, and here 10 meters. Why do we need to mark the plot? Many characteristics are recalculated on the area: number of species, species cover, area of nanoforms, etc. That is why we have to mark the certain area. For this type of peatlands, it is enough to have 200 square meters. From our long-term experience, it is easier to put 2 perpendicular lines than 4. That's why we have special way to mark the square. From the center of the relevé, we mark 10 meters towards 4 directions along 2 perpendicular lines. The ending points of the lines are angles of the square with the area 200 square meters. Please mark in your notebook basic information: date, time, weather, name of the site, and make several overview pictures of the site. When you have several relevés a day, you have to number the photos. You can just keep the number in front of your camera or ask somebody to stand with the number in the middle of the relevé. Take coordinates of the central point of your relevé and every angle of your square. In your notebook, you can put just the number of your GPS. Don't waste your time writing the coordinates, or make the picture of GPS. By next step, you have to record key physical characteristics of the site: peat depth, humidity of upper 10 centimeters of peat, just by ranks from 1 to 5, water table level, and when water reachable, pH and electric conductivity of my water. Water level. The water level, you should not wait when it comes out, but you should identify it immediately. So I go slowly. And now I feel that it is quacking here. So, and measure from the surface to the nail of my quarter out, and I know my total length is 100. Yeah. So it is easy to calculate that the water level is 86 centimeters now. So it air temperature, otherwise it has no sense. We put the air temperature, the temperature on the surface, the temperature of the 5, 10, 15, 20 and 30 centimeters, and for the hammock and for the hollow or for the flat. On the 1.5 meters, 8, and then we put on the surface. On the surface. Yeah. First on the surface. It's 15.6 now, and then we go to 5, yeah, to 10, and with the other deeper using the centimeters. So now we are at 10 centimeters, and this is 8.2, 8.2. We are sure that they are the same. And now at 20 centimeters at 7.3. At 20 it is 7.2. So there's some gradient. This is better to measure with this, much easier. Then we put at the 10, 5, then 10, etc. And here this is all the time 15. And this is the difference, that this peat is preserved, this peat is decomposing actively already now because of the high temperatures. Bacteria are already working and eating this up. The last step before we reach vegetation description is a description of the nanorelief. We remember that the biodiversity of peatlands is expressed in the ecosystem and intraspecific diversity mainly. Ecosystem diversity in peatlands is driven by micro and nano relief. Phytosociology as a science set up the difference between mosaic, spatial diversity, and complexity. Let's look at them. Mosaic is spatial heterogeneity within one phytocynosis class. Elements of mosaic are connected to the nanoforms, like small hammocks, hollows, flat patches. All elements of vegetation are classified as part of one association. The complex of phytocynosis comes up when the units of spatial diversity have so different conditions that their vegetation is classified as different associations. It means that the vegetation of hammocks and hollows is so different that belong to different associations. Clear. Here we have the example of mosaic. Hammocks and flat parts belong to the same vegetation class or association. How to describe nanorelief? The best way is to make several classes, size classes of these hammocks. For example, we have 3 classes by diameter and height, and then we give the size of the hammock, height and diameter, and what percentage covers this class. Why we need this? We saw what is the difference in the temperature, for example. There's the other characteristics. It is very significant to have this characteristic for peatland. We measured with you the peat depth, but a lot of peat is in these hammocks. So this is the additional storage of peat and additional source of greenhouse gases. So it is very significant to characterize this nanorelief. To demonstrate to you how to deal with the complexes, we have to fly to Russia, to the Maya Staroselsky Moh in Tver region, our last year Corona field campaign. Here you see the forested hammock hollow complex and our famous cross in the middle that marks the relief plot. One can designate at least 5 classes within the plot. However, on the ground we have to check if they are microtopes, components of the complex, or some of them are element of mosaic, nanotopes. Here we are on the ground. Looks like we have 3 key microforms which are part of the complex. To designate them at the drone shot and to take into account complexity during our survey, we mark them. There is no way to see any numbers at the drone shot. We use the disposable paper plates to mark our microforms. And we launch the drone for the shot. At the drone shot, you can see our marks. Now we can delineate all microforms and count their area. The other type of complexity. Here we see pools and rivers in combination with lawns. Our famous cross is here, the permanent plot set up. We check on the ground. There is no need to mark elements in this environment. Everything is quite readable and clear. The drone is launched and the shot is here, ready for the delineation and mapping. Landscape. It's not a rocket science, so you just place your plot for your relief as we agreed 200 square meters, for example. And in case of the mosaic landscape, you have to put your entire relief within the borders of this plot, yeah, as we did in this German side. Just make one relief. And when you are dealing with a complex, like we showed you in the Russian side, then you make a separate relief for each association, also within this 200 meters. Just make 3 or 4, how many you have, depending on how many you have, associations, make 3 separate reliefs, but still within this plot. And then, as you saw, we are making these drone shots, and in these drone shots, from these drone shots, we know the exact area which is covered by every association. So then you have also the data about the area covered by your relief. How detailed should be your relief? It really depends on the task. If you are aiming just inventory and mapping of Maya flora and vegetation, so this could be not so complicated reliefs. If you are mapping ecosystem functions and services or mapping for your guest analysis, then you should really address very carefully all structural elements, and especially those elements which are bringing you to the assessment of the productivity. If you are setting up long-term monitoring for ecosystem functions, then you have to set up the permanent plot, and we will address all 3 approaches. What is difficult in the Maya vegetation? That there could be forested Mayas. Yeah, and the forested Maya phytocyanosis have a similar approach as the forests. So you have to characterize all layers. The tree layer or canopy layer and mid-story layers, and regeneration layer and shrub layer and ground layer, which will include herbaceous plants, dwarf shrubs and mosses. Tree layer in peatlands is a very tricky thing. There is, especially in Russia, a lot of discussions. Where is Maya and where is forest? Actually, for me, the criteria is more or less clear. If your trees are still reaching the mineral soil under peat and are fed from the mineral soil, then with high probability they will dominate in the landscape, and they will be so-called edificators, species edificators, which are dictating to other species the rules of game. When trees are losing the connection to the mineral soil and depend only on peat, then this is the other story. And in the, for example, raised oligotrophic bogs in which of temperate zone in which I work the most, then the sphagnum mosses are taking over, and then they are dictating the rules of game. They are becoming so-called species edificators, and then it is already Maya. I know that there is a lot of different cases. There is discussion, for example, if the black alder peatlands are peatlands at all. I am sure that they are, even if black alder trees are connected to the mineral soil. This is just the other peat type of peatland. However, if you go in our model object, which we are now in this terracelia peatland, we see different stands, tree stands, which are changing from the edge to the center. This changing tree composition, changing their cover, changing their height and diameter. And this should be reflected in your relief. So what we are recording? We designate the tree layers in the field. Yeah, so for the stand, what is particularity for peatlands? In the forest, including the Maya margins, where trees are reaching the mineral soil, the rule is that the tree is everything what has diameter more than 6 centimeters. What is less is described as a tree regeneration layer. In the tree-raised bog, the tree, when the trees are not reaching the mineral soil, yeah, the tree starts from diameter 3, yeah, less diameter. Also, in the oligotrophic raised bogs of the temperate zone, we have specific forms of pine tree, Pinus sylvestris. This is the same Pinus sylvestris, which is growing on the uplands, the same genetics. However, in peatland, within peatland, depending on the conditions, on how deep is peat and how long this pine population is staying there isolated from the mineral soil, you can designate the forms. The highest is form oligonosa. This is usually dominating pine tree in the edges. Then comes forma litvinovi, which is smaller. Even having 200 years could have the size and diameter of 6-8 centimeters and height of 5 meters. Then comes the form Wilhelmi, which is shrubby form, And then comes the forma pumili, when the sphagnum on the top of the peatland is growing so fast that it is eating up the pine, and the pine is represented on the surface only by the small branches, and doing its best to grow as fast as possible. You have to look up for your region. It also could be such a forms in the other geographical areas. However, I think that in tropics, where there are plenty of tree species growing in the peatland, there is no such a problem. Because in the temperate zone, the raised box, there's only one species of tree which can survive this. The birch also is left behind when at the margins. Yeah, so, and then the only way to somehow adapt is to change the morpha, yeah, the form, without changing genetics. So, however, you can look at your places. I don't know these cases from the literature, but possibly you also have such examples. And then we usually describe them separately, every form. Okay, so coming back to the layers. So in the picture you see that we have layer 1 of tree layer and layer 2. And sometimes we have sub layer to layer 2. And first what we have to put, this is the composition. So this reflects the percentage of every species, and it's written in sort of formula. For example, if you have 70% of pine trees and 30% of birch, you just put 7 Pinus sylvestris, 3 Betula pendula. And then the second layer the same. You put also formula separately for the second layer, and if you have sublayer, you have formula for the sublayer, and also separately you put a formula for regeneration. This is the composition. Then you give the average height of the layer and canopy density for the layer at this time. And also we always put the percentage of dead stems, because in the peatland very often the dead stems are standing long time in the stand without not falling down, and we have to calculate them in the structure, because they are also the part of the stand structure, even if they are dead. They take their space in the horizontal and vertical structure. Next step, you characterize every layer. For every tree layer, you put the tree species and designate individually for these tree species and for this layer canopy density, average diameter, and average height. You can also make this diameter and height more accurate using not very complicated instruments. You have also not complicated instrument for canopy density. Significant characteristic is the basal area of trees per hectare in square meters. You do it by applying so-called Bitterlich method. You stretch out your arm to 50 centimeters from your nose and look at your upright thumb, which has to be 1 centimeter actually. You turn around 360 degrees and count the number of trees whose diameter appears larger than the width of your thumb. If you multiply this basal area by the estimated average height of the trees on your plot, you can get an idea about the wood stock in cubic meters per hectare. You do this for each species separately. For more accuracy, you can apply the various instruments or one of several special forest measurement applications for smartphones. One example is MOTI, published by the School of Agriculture, Forest and Food Science in Switzerland. So for guest, you have to count every tree in your plot, within your plot, for each layer separately, and put the diameter and height measured accurately by relevant equipment. If you are dealing with a long-term monitoring, you have to set up a permanent plot. It also could be 200 square meters, but in reality for the forested sites, we prefer larger. We prefer 400 square meters. And then you already have to number every tree, put this on the register, map the crowns, map the tree position, and make a lot of difficult procedures, which I did a lot in my life, working 10 years for the forest nature reserve. And but this is only for the long-term permanent monitoring, and in peatlands you will not have many of such plots. Finally, we reached shrub layer. With shrub layer also is a trick. In peatland you find shrubs and dwarf shrubs. Dwarf shrubs, as they have the other name, naturally they are not shrubs. Shrubs are belong to the living form, so-called phanerophytes. This is the plants whose buds spend their winter in the air. And haemaphytes is the living form of plants which have their buds in winter time near the soil or inside the soil. So this is the difference between dwarf shrubs and shrubs. For example, willows or myrica or some small birches, they are shrubs. The all ericaceae which you have in the temperate zone in the raised bogs are dwarf shrubs. However, Myrica galli is also ericaceae, and there are also some ericaceae in different continents and places. For example, in America there is a lot of vaccinium species which are shrubs, so just be careful. Here are examples for the temperate zone of Eurasia. So please describe in shrub layer only shrubs. Shrub layer is described as a whole, as a layer by height in meters and the canopy density in decimals, like 0.2, 0.1, the same like trees. But then you make the list of all species which you have in the plot, and then to species you already give percentages, like as you give it for the ground layer. For example, Salix cinerea covers 10%, Myrica galli 5%. Then you give average height, meters or centimeters, who likes what. And please give to shrubs phenology. Phenology is very significant characteristic in the peatland, because peatland plants have a huge, large variability in biology. It's very significant to pay attention to phenology. And finally, the ground layer. The ground layer is presented by dwarf shrubs, all herbaceous vascular plants like sedges, grasses, etc., and mosses, which we moss layer, which we put as a bryophytes, as we put sphagnums and green mosses together. Sometimes you can give them separate cover, and the separately be give to lichens. So for every this group you give separate cover. So total cover, then cover within the groups, vascular plants, bryophytes, lichens, and then to every species cover, again height, and again phenology. So my advice is, first of all, to make the list of all plants from the plot, then come back and give their characteristic, the average height, the average phenological status, and then to give them percentage. You also can describe if some of them are grouped, and use the other scales, not percentage but Brown-Blanquet scales or Rankier scale. It doesn't matter. It means that the only matters that at the result you have the characteristic of the presence and what is the input, the phytosociological meaning of this species in this community. For all mosses, I recommend to take samples. Even if you know the moss, if you seems to know the name of the moss, you put the name of the moss and the number of sample, and put this sample in the in peatland. It's better to use plastic bags, and then at home you can change it to the paper bags. And now we are on the ground, and this is the end of the vegetation relief, which consists mostly not from vegetation but on preparation. But this is the particularity of peatland survey. And we wish you happy field, and please ask us, we are here around.